Hi, I'm Eli Stringham. I'm going to be showing you how to take this piece of 1-inch bar stock and turning it into a 3/4 10 thread here on this Kingston lathe. So these are the tools you'll need for this project. You'll need your lathe toolbox, the machinery's handbook, the stock material, 6-inch ruler, micrometer, caliper, Allen wrenches, our travel indicator with a mag base, our right hand and left hand turning tool, our chamfering tool, thread tool, a stone, hard off tool, a big wrench for our tool post, our protractor, our thread gauge, pitch gauge, thread wires. So we have a half round, we have a triangle, and then the thread file, sandpaper, Scotch Brite, dead blow hammer, Sharpie, layout fluid, a test nut, cutting oil, or coolant. So when we come to a machine, we want to make sure there's a few different things. We want to make sure that the power is off and then we are in neutral gear. That way we don't have to worry about the chuck accidentally spinning on us while we're setting up. Another thing we want to do is we want to make sure the lathe is nice and clean before we get going. So preferably we'd have this clean the night before, but we just make sure that the ways are wiped down and the chuck is clean itself. So we want to make sure that the chuck is properly mounted. On these chucks on the back side for the nose, these cam locks here, we want to make sure that this dash on the lock itself is in between these two arrows, not in line with this here, because that's when it's going to be open to come off the chuck. And so we just want to make sure that all of these are nice and tight, that we're not going to be spinning it and then have the chuck pop off on us. So, yep, it looks like they're all good. Nice and tight. Okay. Then we'll come in here and we'll get our part into the chuck. So spin these open a little bit so we get some room to do it. So we'll be doing this with the 4-jaw chuck, and I'll be dialing it in so we're within a thou all the way around. All right, let's see, get my 6-inch ruler. So we want to make sure that our part is sticking out at least 1 3/4 inches. That way we have about 1/4 inch away from our chuck that we can be working with without ever crashing our tool into the chuck. So now that I got this in here, I can spin it and we can see that is not centered at all. Bring in our indicator down over here. Now we can see how much travel there is. So if we go from there, 1, 2, almost 1/4 inch difference from one side of the chuck to the next. So where this end is our low spot, we'll need to bring it up about 1/8 inch. So we're going to loosen this side a little bit and then move to the other side, and then we'll tighten it and see where we're at there. So about 50 and about 50 thou with, let's see, this is high now, so we'll tighten that and loosen this and tighten that. Let's see, so they're about in line, and we got our other 2 jaws, so we're about 5 thou there, about 150 thou difference, with this being the high and this being the low. Let's see, 3. All right, so now we can see that is staying within about 1 tick all the way around, and we are a little over 1 3/4 inch sticking out. Now we need to set up our tool to do a facing pass. So we're going to set up with our left hand tool so we can cut across the face of that like this. Now we need to make sure that we have the proper tool height for our tool, so we need to bring it in to the face, and we can use the ruler method to see how straight up and down it is sitting when we press it against the side. Looks like I need to come this way, drop down the tool a little bit. That looks pretty good. Something else we can do is we can bring in the Live Center and bring our tool back. And we can eyeball our tool height based off the center of our Live Center. Now we need to set up our speed for being able to do our cutting. So we're going to use the machinery handbook. So we're going to turn to our turning speeds and feeds. And we're going to take a look at 1018 steel and our high speed turning tool. I'm going to be using 110 to calculate our speed. For our calculation, we're going to do 3.82 times this 110 number. And then we're going to divide that number by 1 inch for our 1 inch bar stock. So it is saying we need to be cutting around 420. Now we'll take a look at our machine and try to see what speeds we have available. On this machine, we have 490 and then 330 are on either end of that. What we have found here for the 1018 is actually 650 is pretty good for cutting. So I'm actually going to be setting it for 650. It'll allow us to cut just a little bit quicker. So we need to be in high gear and we need to be in line with 650. I'm moving over like that. Now that's in gear, we'll turn on the machine and then we'll lightly jog it to make sure that we're actually in gear and the gears aren't going to be grinding against one another. Next thing I'm going to do is I'm going to set up a feed rate so we can have it power feed across. So I'm going to be taking a look at this table here. It says we need to be in I and Y. And then we're going to shoot for about 8 thousandths per revolution. So we're going to go with LR6 for the next. So R, L, and then we're already in 6. Now we're going to jog the machine again because we want to make sure that our feed rod is spinning, making sure that it's actually going to be moving. Next thing we need to know is here on the carriage, or the apron of the carriage, we're going to make sure that we are got this knob pushed in all the way to do the cross slide feed. And then all we need to do is touch off our part. I'm going to feed it in a little bit, and then I'm going to engage. Okay, got to the center, going back out, and I'm going to stop the machine. One thing I can see is we got a bit of a nipple right here. So I'm actually probably a little bit too high on my tool height. So I'm going to drop down our tool height a little bit more so we can try to clear that up. Still a little bit of a nipple, but that'll be okay for what we are doing here. So we need to flip around our tool from the left-hand tool to our right-hand tool, and then set it up to cut along with the carriage feed. I'm going to adjust this just so it will be a little bit more straight and true. Then I'm also going to need to dicom this so that it will give us a nice mark to see where we need to stop. First way that we can do this is by using an air hose and using a Sharpie to spray out the Sharpie onto it. We can also just brush on some layout fluid. I have locked my calipers to be at 1 1/4, and then I'm going to just use them as kind of a scribe tool. So now I like to kind of adjust my angle that I do it at. That way we can get the scribe mark a little bit bigger. For a lot of things, we're going to actually be using our micrometer dial to be able to see where we actually need to be stopping. I'm going to set it up to feed across. So I'm going to pull this out a little, all the way out for our carriage feed, and then make sure that everything else, we're going to keep our same feed rate, cutting across, just need to pull that out. So something we need to know to bring it down to the diameter we need for a 3/4 10. We can look in the machinery handbook. For a 3/4 10, we're going to do a 2A class. So we're going to take a look. Our major diameter for our thread is going to be a little under 3/4 of an inch. So we got 0.7482 and 0.7353 as kind of our range. Now, this number down here, sometimes they'll have it. And that is just kind of like an extra tolerance that they'll give you. But we want to stay between these. Now, for most threads, from 1.5 inches and down, and about 12 threads per inch and smaller for our pitch, we can usually go away with about 5 thousandths under our nominal size. So, rather than going for 3/4, what I'm going to go for is actually a little bit smaller than what our max diameter it calls out in the book. So I'm going to go for 0.745. So now what I'm going to do is I'm going to turn on the machine, and then I'm going to bring the tool in, and I'm going to touch off top so I see just a little bit of that dicum coming off right there. I'm going back off. And now I'm going to set our cross slide to 0. And we'll readjust this in a second. I'm going to move it in about 80 thousandths. And then I'm going to move the tool back in a little bit closer. I'm going to set this carriage feed also to 0. So I'm going to engage it. We're getting our roughing cut. So roughing cuts, we can go about 80 thousandths, 50 to 80 thousandths in feed for it. For finishing, we'll want to go down smaller. So I'm going to disengage right when we get there, and I'll move back. Or go back to 80 thousandths. I'm going to stop the machine. Now that I'm at 80 thousandths, I'm going to measure to see how big we're actually at right now. So, with that, this says we are 16, so 0.916 for our diameter. So if we do a little calculation with our calculator, we can do 0.916 minus the diameter we're shooting for, so 0.745, and we can see that we need to go another 171 thousandths. So roughly 2 more roughing passes, and then we'll do a finishing pass. And we'll measure right before we do our finishing pass, make sure we get right to size. Set this to 0s because I know I need to go about 170. I'm going to go another 80 right here. Now, I'm not loving these chips that we're getting. So I'm going to turn down our speed and increase our feed rate. With high-speed tool, we don't necessarily like our chips to be turning different colors. So I'm going to be bumping that up to 12, so we need to switch to high and high, S, and 2. Give the machine a jog, make sure it's feeding right. Then I'm going to also drop it down to that 490 we had before, closer to what our original calculations was. I like those chips a lot more. Still changing colors, but we're still getting a nice finish cutting across. So rather than backing out, I want to do a finishing pass at that same height. So I'm just going to pull the tool back across. That way I don't have to worry about any backlash in the cross slide when I adjust a little bit more forward. So I'm going to be measuring it again. And this time I am about 10 thousandths above where I want to be. So I'm going to now change our machine to do a finish pass. So what that means is we're going to set it to the highest speed that the machine can do. So this machine can go up to 2,000. So I'm switching it up to 2,000, and then we're going to set our feed rate to the lowest it can do, which is about 1.2 thou per revolution. So we need to get this set to LT1. So LT and 1. Make sure that's spinning. And now if I turn this on, we got that spinning really fast. So I'm going to feed it in about 10 thousandths. In, and then pull the tool out across that face. Nice and clean. Okay, now I'm going to grab my micrometer. That way we can see down to the 10th what our diameter is. So, looks like I am 1 thou under than what I was shooting. The actual measurement is 0.7444. So 6/10 under where I was shooting, but that's all right. Now what we're going to do is we're going to add a relief into this back corner here. I'm going to switch out our right-hand turning tool and switching it to a part-off blade. And then we're just going to go in down to 5/8, and then we can add chamfers after that. Pop that out. Like before, we're going to double check our tool height. And see, I am a little low, so I need to bring it up. That should be good. And then something else that we'll want to do is we'll want to make sure that our tool is perpendicular to our part. A few different ways we can set up a indicator across the face of our tool holder, or we can push it up against our part or our chuck, or even against our tailstock. I'm going to do it with our indicator. I'm going to turn off the machine and switch to neutral, and I'm going to find a good spot that I can set up this mag base so we can run this across. Move this in to 0, and then let's run it across to see how far out this is currently. So from end to end, we're about 35 thousandths out. We'll want to get that dialed in within a thou, loosen our tool post a little bit, and yeah, we're low down here. We are now within a thou. Okay, the mag base out of the way. For using the part off tool, we want to go below 200. So I'm going to set it up for 160. So set it into medium and 160. Turn the power back on. And then we're going to bring this in. We've got plenty of clearance. I'm going to turn this on, bring this tool in so it just barely touches that shoulder that we have. And then I'm going to go in, go until I see it cut in the face of our part. Right there. And I'm going to set our 0 on the cross slide. And then slowly feed in 120 thousandths. Remembering to put some oil on it every once in a while. Okay. And then I'm going to move this out of the way, turn off the machine, and going to measure down there at the bottom. See what we're at. Which we're at 620, so a little under what it's shooting for, but we're where we want to be. Now the next thing we're going to do is we're going to be putting a chamfer on it. We can either be using a chamfer tool like this, or we can use the threading tool itself. Where I have access to the chamfer tool, I'm going to be using that. Double check our height, tool height. And it looks like just a little high. Drop that down, and then we're going to put a small little chamfer on there. Okay, got that chamfer. I'm going to try to get all the oil and chips off of there because now we need to put some layout fluid on there. While that is drying, we can set up our feed rate to be ready to go for our threads. So we'll want to take a look at this part of the chart here, and we are doing 10 threads per inch. So we find 10, and it says we need to be in low B, let's see, low B, T, and the Roman numeral 2, and then 3. And if we double check, our lead screw is rotating. So Then we'll make sure that the carriage, this knob here for the carriage feed, is set for our threads, which is not pushed in all the way or not pushed in all the way out. Goldilocks right in the middle. Then other thing, so there's a chart down here that tells us what number we can stop on with our half nut engagement timing. So for 10, it says that we can use numbers 1, 2, or 3. Now these Kingstons are a little bit finicky, so I would never use the 4 for any of these that say that can use the 4. Use 1, 2, or 3 instead. Where these machines are older, it just has a lot more play, more likely to get off from alignment. So now I'm going to set up our threading tool. Now we need to make sure our tool is perfectly perpendicular. So we're going to use this thread gauge to put our tool in it and then put across one face of this. So our tool into this side and then along our part right here, so we can make sure our threading tool is perfectly perpendicular with our 60 degree. Looks like it's off a little bit. So I'm going to adjust by loosening this here, putting this back in. And then let our tool post kind of do the work by feeding it in along there. Now that I know that's nice and straight, tighten this back up and we can start threading. If this is your first time cutting the thread, we suggest that you set the machine either to its lowest speed or around 52. So on the Kingstons, it can go down to 35. On the Kents, it can go down to 50. So just to make it even between the two, I'm going to set it to about 52. That way, it'll be consistent for both machines. Now, in the machinery handbook, it suggests to go about a quarter of your turning speed. So we could go down to about 110 if we really wanted to, or whatever you're really comfortable with. So I'm going to come in here, get this turn on. I'm going to move my tool into our part until I see it lightly scribe a line. Once we have that line, we'll back off, and I'm going to try to shoot for 3 on every one of these marks. So wait for 3 to come in, slow down lightly, and then fully engage once it gets in there. Now I'm just going to be watching our tool as it comes across. Make sure we don't hit that back shoulder. Once it gets down to the end, we can either disengage the half nut lever or slam on the brake. Now that we got it right there, we can back off and move back to the side. While it is disengaged and stopped, I'm going to double check that our pitch is set up right. So using our pitch gauge, I'm going to just double check on our lines to see if we have our thread marking in there, touching on each one of our lines, which it looks like we are. If it doesn't line up, then you'll need to change your gearing, double check your gearbox to make sure that your feed rate for your thread is set right. There are 2 different ways that we can plunge in and cut our threads. We can use our compound to feed in, or we can use our cross slide. For what we're doing, we're going to show you how to do it with the compound. So going to get this back up. I'm going to also want to set my 0 here on the compound. Then we're going to feed in about 10 thousandths with that, and then come and cut across. Let's see, get it to lock in on 3. Want to pull out, then move back into 0, then move in another 10 thousandths. And we'll do this over and over until we get close to our final dimension. Now we're gotten down in a little ways. We want to take a little bit lighter depth to cut. So rather than 10 thou, I'm going to be feeding in about 5 thou. And what I'm looking for to stop, or where I'm looking to stop, is when we start seeing very little amounts of the blue dye left on the top of our bolt. So once we get down a little bit closer, we'll do a measurement using the 3-wire method to see how far or how much farther we have to go till we get to our pitch diameter. Okay, I'm going to do a couple spring passes. So what that means is we're going to just move. We're not going to move in any more than what we were before, where you come back to the same spot, and we're just going to be cutting out any material from spring deflection from our tool pressure, and try to get that a little bit smoother before we measure with our wires. You can see with this very last spring pass that it's removing a very small amount compared to that first spring pass. So disengage there, going to move out, and then I'm going to bring it back to 0 so I know we're good to go. So with our wire threads, we can see for 10 threads per inch, we need the 55 thousandths wires. So going to look in here, see where our 55 thousandths is, and it is this one, a little bit faded. So we're going to grab these wires out. We'll take a look at this constant number. On this chart, it gives us what we need to know. So we're going to get M for our measurement over the wires, and then E is our pitch diameter, and then plus our constant. So we're going to look back in the machinery handbook for what our pitch diameter needs to be versus what we should be measuring over. We take a look here, we have our pitch diameter. So it calls out 0.6832 to 0.6773. if we add that to the constant that we got, we will get 0.7616 to 0.7557 measuring over our wires. Using our micrometer, we're going to put our wires in here. So what I like to do to try to make it a little bit easier on me is I will do a little bit of a finger trick to adjust these wires to go over top. So I'm going to put 2 underneath, and we need to make sure that they are in different threads on either side. And then using our other hand, we got to be able to multitask and use our micrometer to bring down the micrometer over the wires. And we're going to pull this off and take a look at our measurement. So I am getting 0.7715. So I am about 10 1/10 higher than what I need to be. So rather than feeding in with our compound, I am going to feed with the cross slide. That way I know I can go in 10 thousandths in. And I'm going to do 1 thou increment at a time. Now I'm going to be making sure not to touch our compound anymore. So I'm going to lock our compound. And now I'm going to feed it in. We're going to go until we're at 10 thou there. I'm going to measure again about halfway through just to make sure that it is cutting properly. Let's see, wait till we get to a 3. And engage. It is crucial to do these lighter passes at the end to get the nicest finish as possible. Especially where we're feeding in with the cross slide versus the compound, we are going to be having more of the tool surface area pushing into the part than what we did before. Now I'm going to do a spring pass, and after I do the spring pass, I am going to run a file over the flanks of our threads and over the top a little bit, just to try to clean up any burrs that we might have before I do this next measurement. Now I've only fed it in about 5 thousandths, where I knew from our previous measurement we needed to go in 10. So backing out. And going back to our starting position. And I'm going to blow off. Now you can use different files. I prefer using the triangle file when doing threading, just because it's going to be an equilateral triangle, which matches the 60 degrees for our 60-degree threads. So I'm going to do a light pass over the top of our threads, remove any burrs from pushing material up, and then down in the flanks. Just slowly pushing it across as we move down so we're not sitting on one spot along our threads. And making sure that our start is nice and clean. So it does look like I went about 6 thousandths, so I'm getting 7.5 plus 14, 64, and a little bit more is about 4/10. All I need to do is about 3 more thousandths. This will be our spring pass before we'll do some polishing of that thread before our final measurement. Okay, backing out. And what I'm going to do here is I'm actually going to bump up our speed just a little bit. I'm going to take it to 160. That way it's just a little bit quicker for this polishing. And I like to round the start of the thread and the end of the thread with the file, and I'm going to come and round out that shoulder just a little bit. And one last pass across the flanks. We can take some sandpaper and some Scotch-Brite to help polish that up. And then we also have here a thread file. So on the thread file we have 2 sides with 4 sides to each of those, each having different pitches on it. So for 10 threads, we're going to use this side down. And I'm just going to do that across the face, making sure I keep my hand away from the chuck. Then I'm going to take sandpaper and I'm going to wrap it around. Same thing, keep my hand away, lightly holding the sandpaper, so if the part ends up grabbing and snagging the sandpaper, it'll rip out of my hand. And then our Scotch-Brite. Lightly holding it as I press against it. And we'll get our next measurement. And try not to lose the wires. And there we go. All right. So it looks like I went down only about 2 thousandths from where it was before. But at the end of the day, it comes down to fit. So using a test nut, we can see if it goes on, which it does. And there is little to no slop in this. So I think that's good. We're going to stop right there, and that is our finished part. Side by side, we can see what it kind of used to be to what it is now. So we can see here our threads, and we can take a look at our angles to see how well our threading tool cut this. So I can see that our threading tool is 30 degrees right there, and we flip it around and we can see right there that it's also 30. But there must have been something with the edge of our tool that it ended up cutting not a complete 60-degree point there at the end. But for most of our nuts, the female threads that will go over this, that they would probably stop a little bit higher up on there, and so it would never really matter too much for a 2A classification thread. Now that you've seen it done, go out in the shop and make some chips.